We're in section 4-3 of the book, and our current syllabus in the spring of 2013 doesn't show homework problems for this, but you're supposed to be doing 1.9, 1 to 9, the 19 the odd ones, and 27 to 39 the odd ones. Don't do any one that isn't assigned because that would cause certain problems. Okay, so in 4:13 we have some rules for partial fraction, and it says that if we have something like s over 4, then we would change that to partial fraction of something that looks like this. And we've already done that once. I think we've used that rule before where you end up, we had an s squared sitting down there. If you have a quadratic thing, so I had s minus a squared plus b squared. So somehow I ended up completing the square and had something like that raised to the n. Then I'd have as plus b over s minus a squared plus bn, b squared, plus cs plus d over s minus a squared plus b squared, the quantity squared, plus as many as I need until I get to the guy raised to the n power. And each of these guys I'd have to solve for a, b, c, d, e, f, g, h, I, j, k, l, m, n, o, p. Clearly that would be an interesting problem from a point of view of keeping track of all the paperwork. Then we have an interesting theorem, Theorem 1, that says if I were to take the Laplace transform of e to the at times f of t, that would be f of s minus a. Alright, so let's say I've got e to the at cosine t. I have something, cosine kt. Let's say I have that. And I wanted to take the Laplace transform of it. That would mean I would look at the cosine of kt, and that's s over s squared plus k squared, I think. Or is it minus? Yeah, s plus k squared. So now what would happen is that I'd put s minus a in those positions and call this s minus a over s minus a squared plus k squared. So that's how I would interpret that particular theorem. And using that theorem on page 290, we see exactly what I just did, and then we see the guy for the cosine, and we see another guy. And that ends the theorems, and now we can start working problems. So the issue is, Andrew just walked in the room wanting me to work a problem. What problem do you want me to work?
I don't want you to work a problem. I thought you were working one.
Not yet. But what we did cover is that the syllabus left out section 4.3, and there's homework to do in 4.3. And 1 through 19 odd, and 27 to 39 odd.
Is it the same thing as in 4.2?
No. No, different thing than what's in 4.2. Okay. So I'm ready to work a problem. Let's see what I'm going to do. I'll work number 6. Just for the heck of it. So I have f of s is equal to s minus 1 over s plus 1 cubed. And I want to take the inverse Laplace transform, apply the translation theorem to find the inverse Laplace transform. Okay. That's obviously not what I would do.
If you break the cube down, won't the s minus 1 cancel?
Oh.
Isn't that the first series in it? S minus 1 and s squared plus a b and
No, I don't think so. See, you're saying that this guy here is s cubed plus 3s plus s squared plus 3s plus 1. That doesn't help me any. What I'm thinking is they gave me a way to work it that isn't going to work, but I would do partial fractions on it. I'd say that this is a over s plus 1 plus b over s plus 1 squared plus c over s plus 1 cubed is what I would do. And then I'd ask myself, if I had c over s plus 1 cubed, could I find, yeah, I can find the, that's number 16 on my Laplace transform table. So I could find that guy. So that's probably what I would do. And then I'd say, well, gee, this is going to be as squared plus 2as plus a plus bs plus b plus c, and that has to equal s minus 1, the guy that's on top. And then I look at the s squared term, and I get an a, and that clearly has to be 0. I look at the units term, and I have a b for the s term. A is 0 already, so that implies b is equal to 1. And then I have the unit term, a, which is 0, plus b, which is 1, plus c has to be minus 1, implying that c has to be minus 2. So I could rewrite this as 0 over s plus 1, 1 over s plus 1 squared, minus 1 over s plus 1 cubed. And then I could go and do a inverse Laplace transform. And do I have an s squared? Yeah, I do. So this is number 15, and this is number 16, and I end up with t e to the a t, and what is a? Minus t. T e to the minus t minus the 16 guy, so that'd be t squared e to the minus t divided by 2. Okay, so that's how I do that problem. Now we'll look at number 8. Fine, I'll look at number 8. F of s plus 2, s squared plus 4s plus 5. That looks like s plus 2. If I complete the square, I can have s plus 2 squared plus 1, right? Alright, so I completed the square, I ended up with that, and now I can use the translation theorem that says f of s minus a. So a is minus 2, and we just come up with f of t is equal to e to the minus 2t, and that would be a sine, right? Sine, or is it cosine? Cosine. Cosine square root of 2t?
Whatever k is.
Yeah, so k would be the square root of 2, for that to be 2. square root of 2t. And now I'm using, now in that case I actually,
K is 1. Just
um,
S minus A parentheses and then plus K squared.
right, k is 1, you're right. T. So now I didn't go to my Laplace transform. I used the method I was supposed to. I'll now move on to number 10 and try to do the same thing again. And if I could find number 10. F of s, 2s minus 3, 9s squared, 12s plus 20. Well, isn't that special? What can I factor that bottom guy? If I go let's see, if I go 3s minus 5 minus 4. Does that give me a minus 12? No, that gives me way too much. What would I do with him? I wrote him down right. S minus 20 plus 1. That doesn't do me any good. Okay, well, I don't see it. Anybody see it out there? I can factor a 2 out of there and get an s minus 3 halves, right? I could go and 2 times s minus 3 halves. But I don't see what I'm going to do with this. Well, let's see. Back of the book, see if there's a hint that's going to send us the right way. Probably just send us down another path. This is 9.
10.
This is 10. Oh, I don't like that answer. 136 e to the 2t over 3. Yeah. That doesn't look that intuitive. It looks like we should skip him. Okay, now that we've done that, use partial fractions to do what we have down here. Okay, why don't we do 16? 1 over s squared plus s minus 6, the quantity squared. Okay, so we're going to have a over s squared plus s minus 6 plus b s squared plus s minus 6 squared. Or I think we need to have as plus b, don't we? ds plus c. Yes, we do. Okay, well, I'm going to have as plus b plus ds cubed plus ds squared minus 6 ds plus cs squared plus cs minus 6c.
How come the B's and C's have bigger exponents? Isn't the A and the B the side that means?
See this guy? Oh, bummer.
You have to use it backwards.
What? Anybody know what time it is? Must be in the afternoon sometime. Okay, as I was saying, as cubed plus as squared minus 6as plus bs squared plus bs minus 6b plus ds plus c divided by s squared plus s minus 6, the quantity squared. Okay, so I look at the s cubed term and I get a, and that has to be 0. And I look at the s squared term and I get a b, and that has to be 0. I look at the s cubed term and the s term, and I get a minus 6. I get b. I get d, which has to be 0. And then I look at the unit term, and the unit term is only c, which is a 1, and now I haven't done anything for anybody to get the right answer. That was really great. Wasn't that great? That was just so Marvy. That borders right up there. Okay, so I'm going to try again. What are we doing? Number 16. All right, so I got 1 over s squared plus s minus 6, the quantity squared. I'm going to complete the square on this guy and call him s plus a half squared minus what? Minus 24 fourths minus 23 fourths squared. Did I do that right?
Want to do 25 for us?
Yeah, I think so. That'd be a better answer. 25 fourths. Why is 25 fourths better? Oh, that's much better. Okay, so now I've got 1 over s plus 1 s minus 5 halves squared, the quantity squared. I don't see where that's going to help us any, but you know, at least we're in the right form now, right? So this is going to be as plus b divided by s plus 1/2 squared minus 5 over 2 squared plus cs plus d over s plus a half squared minus 5 halves squared, the quantity squared. Okay, I see that that is definitely a pain in the rear end, but other than that, it looks like So I've got as plus b times s plus a half squared minus 5 over 2 squared plus cs plus d is going to have to be 1. I don't think that this is any different than I had before, is it? I mean, this guy down below is still going to be s squared plus s minus 6, right? S squared plus s minus 6. And I'm still going to get as cubed plus as squared minus 6as plus bs squared plus bs minus 6b plus cs plus d, and that still has to be 1, and a still has to be 0, and b still has to be 0, c still has to be 0, and I have d is equal to 1, and I got absolutely nowhere twice in a row. So what am I doing wrong? And that's exactly what it tells me to do on page 289. Okay, well, where's my delete out equation? So there's that guy. Interesting. Well, isn't that great? Now I know why I skipped this section. All right, well, let's see. Why don't we move on to number 28 and see if we can have more fun. Number 28. Before we do that, we'll look in the back of the book at 16 and see what it says about 16. Okay, well that's nice. I'm sure I'm glad that it did that. But I don't see how I'm going to get that if all my coefficients come out to be 0 except the one that's already there. Now let's do 18. Seems to me like we ought to do a problem, right? In the problem set. S cubed s minus 4 to the 4th power. Okay, so we're going to have a over s minus 4, b over s minus 4 squared, c over s minus 4, that's a cube, this is a square, no, that's a square, this is a cube, plus c over s minus 4 to the 4th power. Okay, that's interesting. Okay, so I got as cubed minus Pascal's triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? Okay, so this would be a 3. 3 times 4 is 12. As squared. 3 times 16 is 48. 48 plus 48 as cubed, as period, minus 4 cubed is 64a. Okay, plus, did I do that one right? Oh, I hope so. All right, so this is going to be bs squared minus 8bs plus 16b. This guy's going to be 6cs minus 4c, and this guy's just going to be a d. And that's supposed to equal 1. No, it's not. It's supposed to equal s cubed. S cubed. Okay, so I look at the cube guy, and I have an a, implying that a is 1. Oh, look at that. We actually got a number. I look at the S2 guy, minus 12, because a is 1, plus b is equal to 0, implying that b is 12. I look at the S term, and I see 48a. A is 1, so it just be 48. 48 minus 8 times b, which is 12, plus c has to be 0, implying that c is equal to 48? 48. Put my calculator away. And then I look at the unit term, and I see that minus 64 plus 16 times 12 minus 4 times 48 plus d is equal to 0, implying that d is equal to minus I got rid of everything in my calculator. Minus 64 plus 16 times 12 minus 4 times 48, and that means that d is 64, I think. Okay, so now I've got a, which is 1, so I have 1 over s minus 4, and then I have 12 over s minus 4 squared, and then I have 48 over s minus 4 cubed, and then I've got, why is this a negative sign? Anybody know? 64 over s minus 4 to the 4th. And then I'm going to take inverse Laplace transform of the whole thing, and this guy becomes e to the 4t. And what in the world do I do with that guy? Okay, that's number 15. Okay, so this is number 15, and I get 12t e to the 4t. And this guy here is going to be number 16. And I'm going to get 48 t squared e to the 4t divided by 2. And this guy here is also number 16. And I'm going to get 64 t cubed e to the 4t divided by 3 factorial. And now I can write down my final answer. E to the 4t, 12t, e to the 4t, 24t, squared e to the 4t. 64 doesn't go into 3, right? So that'd be 32 over 3t cubed e to the 4t. And what do we think about that? The instructor's blowing smoke, or did I actually get one right? That was 18. Oh my goodness gracious, okay. I had to check one up for the good guy. Boom. Okay, now we're skipping the 20s. The 20 to 26. So we're going to look at 28 next. Number 28. X double prime minus 6x prime. 8x is equal to 2. X at 0 is x prime at 0 is 0. Alright, so we're just solving those, hoping for the best. So we're going to take the Laplace transform of the whole thing. I'm going to have s squared x of s plus the stuff that's all 0 minus 6s s of x plus 8 x of s equals 2 over s. Remember that 2 over s thing, because that's going to hose you over on your next test, and you're not going to put that s there, you're going to get the wrong answer. S squared minus 6s plus 8 x of s, 2 over s, x of s, 2 over s, s squared minus 6s plus 8. So we check our Laplace transform tables, and we don't see that one. Bummer. So that means we're stuck with a partial fraction. A over s plus b s plus c over s squared minus 6s plus 8. It's always one power less on top than it is on the bottom. Unless I have multiplicities of them, then I have to do something else. Okay, so now I'm going to go and get the common denominator again. A(s) squared minus 6as plus 8a plus bs squared plus cs over s squared minus 6s plus 8. I look at the s squared term, and I have a plus b. And a plus b has to be 0. And then I look at the s term, and I have minus 6a plus c, and it has to be 0. I look at the unit term, and I have 8a, and it has to equal 2. That 2 sitting right there. Oh, excellent. So now we have that a is 1/4. And if a is 1/4, then b has to be minus 1/4. And that means that c has to be plus 6/4, which is 3/2. Okay, did I do that right? Oh, I hope so. So now I've got 1/4 over s plus a minus 1/4 s plus 3/2 over s squared minus 6s plus 8. And is there some good reason I don't have an s sitting there? I don't know. I don't think of any. Okay, so there's my f of s. I'm going to do a inverse Laplace transform, hopefully. In what are we going to do with this guy? We're going to complete the square on him. That's what we're going to do. So I've got, this guy's going to be 1/4, right? So 1/4 plus. We'll change it. We'll just make it 1/4 s for right now. Minus 1/4 s minus 3/2 divided by s minus half of this is 3, right? So that'd be 3 squared. And then that would give me a plus 9, so I'd make that minus 1. Okay, but if it's minus 1, then I don't have a Laplace transform in my Laplace transform table that'll deal with it. So is this a hyperbolic sine, hyperbolic cosine thing? Is that why I'm sitting that way? And I'm pretty sure it's a hyperbolic sine, hyperbolic cosine thing, but now I have to go find it. Huh? I don't remember. 28. Did I make a mistake? Is that what you're going to tell me? See, when I have a plus k squared, that makes it a sine cosine, but when I have a minus k squared, I think that makes it a hyperbolic sine and cosine, but I don't see where I have solved that yet.
I think they use number 14.
You think they're using number 14?
Yeah.
It's the right spot. Oh, yeah, number 14. Yeah. Why am I? Yeah. But if I'm going to use number 14, then I don't have to do this partial fraction thing either. How lovely. All right, so where were we? We're at 2. Well, okay, so we still have to do the partial fraction thingy. All right, so I do the partial fraction thingy, but then I have 1/4 s plus minus 1/4 s plus 3/2, and I can factor that s minus 4 s minus 2, right? Yeah, now I can use number 14. Okay, now, what do I need on top? I need an SA. All right, so A is positive 4, and B is 2. So I want this to read 4s minus 2 on top. Okay, so I want this to read 4s minus 2 on top. So I've got 1/4s plus I bring out the minus 1, and I make it a minus 1/16. Okay, if I make it a minus 1/16, then I can have 4s minus 2, s minus 4, s minus 2, plus some residual, s minus 4, s minus 2, as a residual thing. Now, what is my residual? This is positive 1/8. So I have a positive 1/8. I take away from that. So I have 3 halves minus 1/8. And I have 11/8. So I have 11/8 over there. Okay. So this guy's still 14, but this guy turns out to be 12. Number 12 I'm using on him. All right, so I got minus 1/4 s, minus 1/16, 4s minus 2, s minus 4, s minus 2. Okay, now I want a minus b on top, which is a 4. A 4. Did I do this one wrong?
Yeah, that 1/16 goes back little section in front. That's not number 14. That s has to be on both of those terms on top. This s is distributed in the equation.
Yeah. Yeah, so I didn't do that one right. Okay, so what? So this is okay up to here. We'll get rid of those guys, and we'll look at it again. Okay, so I want a 4 of 4 minus 2. So I want a 2s on top. So I want as a 2s, s minus 4, s minus 2. Okay, so that's what I want on top. And to have a 2s, I'd have to bring out a minus 1/8. Okay. And then
How do you get to
4 minus 2 is 2. How did I get 2s?
But there's no s in the second term.
Yeah, it is. 14. Number 14, s
I mean, in your equation
times the
before,
quantity.
2/3 or 3/2 doesn't have an s in it.
That's right. I'm dealing with that now. So I'm not dealing with this at all yet. I'm only dealing with that part.
Okay.
Now I'm dealing with this part. And in this part, I'm going to want a 2 over s minus 4, s minus 2. And to have a 2 there, I'm going to have a 4/3 on the outside. Okay, now this is number 12. This is number 14. And this is number 4. Now I'm set to do a inverse Laplace transform of everything. Okay. Change colors. F of t equals 1/4 minus 1/8 4 e to the 4t minus 2 e to the 2t plus 4/3 e to the 4t minus e to the 2t. Okay, so 1/4. Okay, so I've got 1/2 plus 4/3. 1/2 plus 4/3 6 e to the 4t what happened here? This has to be a plus sign. And then I got 1/4 minus 4/3 minus 13/12 e to the 2t. Did I do it? Did we do it? Or are we still just smoking? What problem is this? 28. Is that a yes or no?
No.
That's a no.
There's no fractions in it. One of them has nothing on it.
I used to have a paper clip marking my spot. So we're doing number 28. I've got 1/4 minus 1/2 plus 1/4. Well, at least I got the 1/4 right. What more do you want? 1/4. So I'm supposed to have 1/4 minus 1/2 e to the 2t plus 1/4 e to the 4t. Well, that is just so good, so close, we should probably be able to find that error, right? If we do, now the issue is, do we trust the grad student that did the problems for us? Okay, so how sure are we about this partial fraction thing? A plus b is 0. Pretty sure about that. Minus 6a plus c is 0. Pretty sure about that. 8a is 2. A is 1/4. B is minus 1/4. A is 1/4. That's 3/2 with a minus sign, so c has to be 3/2. So we're pretty sure about that. Put that there, put that there, put that there. Do that fraction. I'm pretty sure we want a 2 there. 4 minus 2. So I want a 2 there. To get a 2 there, I have to bring out a minus an 1/8. Okay, this guy's sitting by himself over there. I need a 2 here. No. No. Not, no. This is 3/4. This is 3/4. Okay, so now I've got minus a minus 1/2 plus 3/4, making this 1/4. I have plus a 1/4 minus 3/4 plus 1/4 minus 3/4, making this minus 1/2. Check. Okay, excellent. Found the mistake, corrected the mistake. What more can we possibly want? Let's do 34. Fine, that'd be a good idea. If we do 34, then we can just go home, right?
Agreed.
Huh?
Said agreed.
Do we have to get it right before we go home? Oh, you guys are no fun at all. X to the 4th power plus 13x double prime plus 36x is 0. x at 0, x prime at 0, x double prime at 0, 0. No, x at 0, x double prime at 0, 0. But x prime at 0, x prime at 0 is 2. And x triple prime at 0 is minus 13. I almost missed that one. Okay. Keep our wits about ourselves. Don't overreact to the obvious. I'm doing 34. Did I write it down right? Yes, I did. Is this the last problem in the problem set I'm supposed to do? Yes, it is. Okay. Okay. So, this is s to the 4th x of s minus s cubed x at 0 minus s squared x prime at 0 minus s x double prime at 0 minus x triple prime at 0 plus 13 times s squared x of s minus s x at 0 minus x double single prime at 0 plus 36x of s is equal to 0. Okay. Applying some of the initial conditions, x at 0 is 0 is 0. X double prime at 0 is 0. Okay. So now I've got s to the 4th x of s minus s squared 2s squared minus 13 for plus 13 plus 13s squared x of s minus 2 times 13 minus 26 plus 36x of s is 0. Okay, so I got s to the 4th plus 13s squared plus 36 x of s is equal to. Okay, now I got this guy, 2s squared. I've got a 13, and then I've got a minus 26. So that's going to give me a plus 13 on the other side. Okay, don't put a divide line down here. Okay, so now I've got that x of s 2s squared plus 13 divided by s to the 4th 13s squared plus 36. Okay, that's good. And I'm just so pleased with that. Are you guys pleased too? 36. That's 6 times 6. That's not going to factor very well, is it? And when not only does it not factor well,
9 times 4. 9 times 4.
9 and 4? Oh, it factors perfectly. I was just about to say that this thing factors quite well. I don't believe that we didn't see it before. S squared plus 9, s squared plus 4. That, now what could be so obvious? And this is obviously s squared plus 3 squared, s squared plus 4 squared, so that's good things because now we have sines and cosines, right? All right, now I'm going to do a partial fraction, as plus b over s squared plus 9 plus cs plus d over s squared plus 4. And then I'm going to have as cubed plus 4as plus bs squared plus 4b plus cs cubed plus ds squared plus 9cs plus 9d is equal to, I put the equal to on the wrong side, equal to 2s squared plus 13. Okay. And then this is under a common denominator, but we're going to just skip that part and say, I'm going to look at the s cubed term, and I have a plus c is 0. I'm going to look at the s squared term, b plus d is 2. I'm going to look at the s term, 4a plus 9c is 0. I'm going to look at the unit term, which I can't look at because I got rid of my equation, and I have 4b plus 9d is 13. Now, if a plus c is 0 and 4a plus 9c is 0, what is our conclusion? Huh? Okay, so our conclusion is a is 0, b is 0. Yes, What?
A if you're equal to 0, yeah, you're 1. You got it.
B and D are 1. B and D can't. Oh, this is 13. Yeah, if I would have wrote this better, then yeah, I mean, and B is equal to D is equal to 1. Okay, so that being the case, I have 1 over s squared plus 9 plus 1 over s squared plus 4 is my x of s. And now I do an inverse Laplace transform on that. And I say, well, I need a 3 on top, don't I? Yeah, I need a 3 on top. So this is going to be 1/3 sine 3t plus 1/2 cosine 3t is my f of t. Now we could go and look in the back of the book. That's one way we could do this. But we know it's not right. Why do we know it's not right?
Because there shouldn't be a different sine or cosine when we say 3.
Oh, this is a 2. No, that's not a problem. It could have, no, that's not the issue, no. What is f at 0? This is, this is x of t, x of t. What's x at 0? X at 0 is 1/2, right? Is that our initial condition? No, x at 0 is supposed to be 0. So in our enthusiasm, thinking that we had everything right,
Would it be half sine t?
even if it were a 1/2 sine 2t, which of course it is, that still doesn't make any difference because, oh yeah, it does make a difference. Huh, yeah, it makes a big difference. Excellent. That, what did you do? Look in the back of the book, or did you?
I'm looking at the cross thing.
No. Oh, you're looking someplace where you actually used the right Laplace transform table? Is that what you did? What a novel idea. All right, so our first guy checks x prime of t 3/3 cosine 3t plus 2/2 cosine 2t. X prime at 0 is 2. Is x prime at 0 supposed to be 2? Yes.
Yep.
Yes. Yes. Thank you very much. X double prime at t 9. So that's going to be 3 minus 3 sine minus 2 sine. X double prime at 0 is supposed to be 0. Check. X triple prime t minus 9 cosine minus 4 cosine, and x triple prime at 0, I hope it's supposed to be minus 13, and it is. Check. And now if we take the fourth derivative, I would imagine we're going to get it to check again. That's it. It's going to be 27 sine, and it's going to be plus 8 sine. And we're supposed to take one of those guys and 13 of those guys and 36 of these guys, and we're supposed to get 0. Okay, so 3 goes into 36. That's 12. 12 there, and then I've got minus 3 times 13. 12 minus 3 times 13, and then I've got plus 27. Plus 27 equals 0. Boom. Plus. I got half of that, so it'll be 18. Then I've got minus 26. And then I've got plus 8 is 0. Oh my goodness. Something's wrong.
Could those
Yeah.
signs also be cosines? Look at number 8 and 10 on the Laplace transform sheet that you gave us.
8
8 and 10. I
and
mean,
10.
you use either or.
No, I need an S on top. There's no S.
Oh.
No, I have to have an S on top.
Okay, never mind.
Yeah, there's no S on top of that, so no, I can't do that. If the A or the C, if the A or the C would have been a number, and then B and D would have been 0, then I would have had cosines. Yeah. But I can't have cosines because that's not the case. Okay. Tomorrow, class, we have Thursday, we're going to have class. Then we're going to do spring break. Then, after spring break, I won't be here Tuesday because I'm traveling across Connecticut, so I won't be here. So that means the next class will be whenever. So 3, 4, 6. The test probably isn't going to be until my birthday in April, or after my birthday in April. Okay?